about radians as what? The circumference of the circle, right? Traversed by that what we call, this is what we call as a unit circle, right? So when you say it's a unit circle, it means that the radius is equal to 1. Are we good? So put here, r is equal to 1. You good? Get it? Okay. So with that being said, what's the circumference formula? That's 2 pi r, right? So 2 pi times 1, which is 2 pi radians, that's the whole circumference, right? So with that being said, we can say now that 360 degrees is equivalent to 2 pi radians. Now, since both are even numbers, we can both divide by 2. Hence, we can say that pi radians is equal to 180 degrees. Good. So that's where we're going to get our conversion factor. Okay. So let's read our step number 1 for such and answer maybe one of these questions in here. Let's try to answer number 28. Right. So we have in here the following. Number 28. Negative 5 pi over 4 radians. How many degrees will that be? Good, right? So negative 5 pi over 4 radians. How many degrees will that be? Okay. Let's read step number 1. All right. KT, right? KT, can you read step number 1, please?
Multiply given angle measured by 180 over pi radians or pi radians over 180.
Alright, so we're going to multiply this one by 180 over pi or pi over 180. Which one among those two should we multiply this with? Let's read step number 2. Alright, Olivia, can you read step number 2, please?
The goal is to cancel to given unit. This means that the desired unit must be above.
Thank you, right? Whatever your desired unit is, degrees, should be the one on top of the multiplier, right? So which one in here has degrees as the one on top? 180 over pi, right? So I'm going to multiply this one out by that, right? Because my desired unit is what? Degrees. That means that's the one on top. We go? All right, so let's do that one in here. Let me just remove this number and multiply this by that, okay? So here it is. Let's see what we got. 180 degrees on top, because that's what your desired unit is, degrees. And below is what? Pi radians. Okay. Now, what do we do then? Let us continue with this. Step number 3. Let's read that step number 3, all right? Kylie, go ahead, please. When working with
pi values, only consider its number coefficient and simplify.
Thank you, right? If you're working with pi values, meaning if pi value remains, then you just concentrate on the numbers without the pi and simplify that fraction. If not, let's see. You see, what's happening to the pi in here? It will cancel out, right? Again, this one is radians, right? So this radians and that radians will cancel out. Good. Hence, we just have degrees, right? So what do? Well, the pi's will cancel out. Just multiply 180 and negative 5 over 4, right? So we can use our decimals for such. Put it in here as follows, okay? So there we go. Click on, a big face in there, right? So that is in the blackboard, right? So anyway, let's put it in here first, right? 180 times, what's that? Negative 5/4. And we got our answer for such, negative 225 degrees, right? So with that being said, then this is what? Negative 225 degrees as an answer. Are we good? Alright. Now, let us visualize, alright? So that will be actually our step number 4 on how to visualize negative 225 degrees, alright? So where is that one? So, let's go in here. Let's click on the polar axis, right? So click on that. Graph settings, click on the polar coordinate axis. You can click on radians, there we go. And see where in there is negative 5 pi over 4. Good, So when you say negative, that means what? Clockwise rotation, right? So you always start where? At the, here we go. Annotate, there we go. Okay. So you always draw this one as your, what we call the initial side, right? That's your initial side. Step number 1, right? Along the positive x-axis, that ray as your initial side. Next one. Negative means what? Negative means clockwise or counterclockwise rotation. Clockwise rotation, right? So negative means clockwise rotation, right? So that means when you say clockwise,
Positive to negative.
okay, so you go to your watch, you use the analog, right? The analog watch, right? Not the digital. And you would see how the second hand, minute hand, and hour hand moves. That's the clockwise rotation, right? So from here, it says what? Negative 5/4, right? So in here, where's that? Negative 1/4, negative 2/4, negative 3/4, negative 4/4, negative, okay, where is that one? Somewhere here, there we go. Negative 5/4, right? Good. Right. After that, what do? You draw in here what we call the terminal side, right? Terminal side, array. Clockwise rotation. So this now is equal to what? Negative 5 pi over 4 radians. Good. Yep. Where's the degrees? Well, here it is, right? If I go back in here on the graph settings again, you see that radians, I'm gonna change it to degrees. There we go. Degrees. That's it, right? So negative 225 degrees is in there, right? So this is a negative 45, negative 90, negative 135, right? Negative 180, and that one is negative 225 degrees, right? Clockwise rotation, because it is negative, right? Now definitely there's a hanging question in here. Mr. Deal, it says in there 135 degrees. Yes, that's positive 135 degrees if you think of that one on this side, okay? And this side in green is basically what we call the standard angle. And we're going to talk about that one later, right? Actually, these negative measured angles are actually called co-terminal angles as well. But the standard angle is how your Desmos polar coordinate is set up. Cool. So later we're going to deal with that as well, right? What is coterminal and how different it is and how related it is from standard angle as well. Any questions with that? Conversions. Cool. Now, let's go now in here to what we call arc length. Okay, so let's read in here first. What do we mean by arc length? And answer one specific question in here. Can I X this out, guys? You get the illustration? Again, as a summary in here, in drawing angles, negative measurement means from the positive x-axis, you go clockwise, right? Clockwise. We have an analog clock in here. Oh, look at that. Hour hand, minute hand, second hand. They're all clockwise movement, okay? Positive means counter that, right? Opposite that rotation is counterclockwise. It's positive.
Standard what? Standard angle?
Standard angle. There we go. And later we're going to deal with standard angle as well and how related that one is to what we call our coterminal angles, right? Let me just give you a hint for that one. The coterminal angle and angles and standard angles are similar in such a way that their initial and terminal sides are the same, right? However, how they were oriented, right? Are they oriented clockwise, counterclockwise, or some more other rotations, full rotations after that? Then that's gonna tell us whether it's standard or coterminal. Later, we're gonna deal with that. We cool? Let's now deal with arc length. Okay, so here is our arc length and see what we got from here. All right, let's read these instructions in here first on how to get the arc length, all right? Let's see in here, which one do you want us to solve, guys? 40, 41, or 42? Choose your own problem. Go ahead. 41, okay. Please go ahead and read number 41, please. Thank you.
Find the length of the arc of a circle radius 5.02 miles suspended by the central angle of pi over 3.
Thank you. All right, so that is our question for that one. So this is what we call our example for arc length. All right, so for arc length, it's a part of the circle. Actually, it's a part of the circumference of the circle, right? With radius r and a central angle theta. Okay? So with this being said, consider the given values as either s, the arc length, r, the radius, or theta, the angle. Cool? So in this case, what number is that? 41, right? So for number 41, we can draw it like such. Your theta is what? Pi over 3 radians, right? Your r is how much? It says how much?
5.02.
5.02 miles, right? So your radius in here is 5.02 miles. Good. So check. We got the r, we got the theta. Good. Next one. Let's read step number 2. All right. Go ahead, sir. Also consider.
Also consider angle measure is in degrees or radian.
All right. So pi over 3. Is it in degrees or is it in radians? Radians. Thank you. All right. So how do you know if it's in degrees or radians? If you see that small circle on top of it, that's degrees, basically. Typically, if you see pi, automatic, it's radians. Good? Okay. Now, step number 3. Let's use the formula triangle, right? So I made this as a triangle simply because sometimes it's just not the arc length that you need. Okay? If you need the arc length, you just multiply the radius and the radian, measure in angle. We good? However, sometimes if you need the angle in radians, then you divide the given arc length and the radius. Cool. And lastly, if you need radius instead, then you divide the arc length given and the radian measure angle. Okay, so again, that's why I made it into this triangle, so that it depends on what you need and how you solve for it. So in this case, what do we need? We need the arc length, right? So to get the arc length, you multiply the radius and the degrees. Are we cool? Right, so let's do that one. S, arc length, is equal to r times theta. Again, that is in radians. What's your radius again? 5.02 miles. Get it? What's your degrees in radians? Pi over 3. So pi over 3. So with that being said, well, we can just use our calculator for such. Did it say, by the way, how much we need to round it off? Well, let's see. It says in here, round to 2 decimal places. Okay? So, once again, let's just use our decimals calculator and work on it here, like such. Right? So let's put it in here. What's that again? 5.02
Times pi over 3.
5.02, right?
Yeah.
5.02 times pi. By the way, in your decimals, just type in pi for pi. That will work. Divided by 3. So with that being said, rounded off to 2 decimal places, that's 5.26 miles. Alright, so this is your answer for such 5.26 miles. By the way, if your angle is in degrees, then this is the formula for such, alright? Pi r times the degree over 180. Are we good? Right? Okay, so once again, you use this formula if the angle measurement is in degrees. Okay? Last one. Illustrate. Well, we have illustrated that one. So where is this 5.26 miles? So that means from here to there, that is basically your what? 5.26 miles. This part of the circumference of the circle is the 5.26 miles. Are we good? Questions? I'll give you one more minute to, reflect on that arc length formula before we go to last one in here, what we call the sector area. Ready? Okay, so sector area in here, okay? Okay, ready guys? Sector area in here. Let's talk about something that has the angle measure instead. What is that number? 46, right? Can you read that one, number 46 in there? Susan, please. Thank you.
Should I read it?
46, yeah.
The sector of the circle at the central angle of 45 degrees and a radius of 6 centimeters.
All right, so what do we need to find? The sector of a circle. We cool? All right, so let's do this one in here. Ready? Okay, so what's that gonna be? Okay, let's read the step number 1. Right? Go ahead, please.
Consider the given value of the meter estimate for the
Radius
times degree.
or degree. All right, so in this case, what is the given in there? It says, the given says what? What's the theta in degrees? 45 degrees. You get? Right? What's the radius? What do you say the radius? What the radius was?
6 centimeters.
6, is it 6 or 16? 6 centimeters, thank you. So check, we got the radius, check, we got the angle. Cool, right? Step number 2, let's read step number 2, all right? Sir, go ahead. Yeah, step number 2.
Is angle in degrees or radians?
Is it in degrees or radians? Is in degrees, all right? So with that being said, there are 2, just the same as the arc length, there are 2 versions of the sector area formula. So which one are we gonna use, all right? So for sector area, if it's in radians, 1/2 r squared radian measure. We good? If it's in degrees, the formula is what? Pi r squared, right? Basically the area of a circle, right? Times what? Degrees over 360. Good, right? So in this case, should we use the radian or the degrees? The degrees, right? Because in here it says degrees. So we're gonna use that one in here. So that means in here, sector area is equal to pi. R is what? 6. You square that one, right? And multiply that one by what? 45 over what? 360. Okay, so this will cancel out. By the way, this 6 is centimeters, right? Yeah. And yes, let's see this one. It says what? Round off to how many decimal places? 4 decimal places. Let's put it on your calculator. Once again for decimals, pi, just type in pi, times 6, you square that one. And then multiply this by, what's this, 45 over 360. Good. And what did we get in here? 14.1372, right? So I'm gonna put in here 14.1372 square centimeters. Good. Okay. After that, let us illustrate, right? So how does that look like? So let's illustrate in here. Let's have our circle in here. 45 degrees is somewhere in here, all right? So that's your 45 degrees. Right. Your radius is 6 centimeters, right? So where is that 14.1372, right? So the 14.1372 is this part, right? This shaded part of that circle's area, right? And that is your, once again, approximately 14.1372 square centimeters. And again, that is your sector area. How we go? All right. Done? All right, can you stop that one already? Questions, guys?